Now we'll do functions. We look at the two functions that is given to us. We're in question 4. We are given two functions, and let's take a look at the function that we have. We have this, which is our parabola, and we have our hyperbola. So we're given two graphs, the f at x and g of x. This is our g of x, and this is our f at x. They are drawn below and have the following properties. We have point A, 5 over 2 and 0 is the point on f, and P is the turning point of f and lies on the vertical asymptote G. The vertical asymptote passes through 1 and 0, and the horizontal asymptote passes through 0 and 2, and the graph G passes through the origin. So we also need to check if everything that is in the statement is also there in the graph. So we can check the point A is there. We also have the vertical asymptote there, and we also have the horizontal asymptote also shown there, and we have the graph is passing through the origin. That's the point right there. So it means we have a point of symmetry. Point of symmetry, which is this point. Let me just write it as a point of symmetry. Will actually be your x value will be 1 and your y value will actually be 2. Good. Remember, we haven't answered any question. We're just looking at the statement and the graph and the function that we have. And then we move on to the first question. Our first question is the side. Let's just move into the first question. Zoom in into the question and the graph. Let me just erase what is drawn on the side. So the diagram is clear. So we are going to write the equations. Show that the equation of g can be written as y is equal to 2 over x minus 1 plus 2. So we are going to use our point of symmetry. Let's get a bit of space. So we can say our g of x, will actually be a, as given to us, x plus b and then plus c. Then our g of x will be equal to a. We're going to have the value of a, we have x, and then if you look at the our point of symmetry, the x value is actually at 1, so it means the graph has actually, we can say, let's move to the left by 1 unit from the original hyperbola. So it's just going to be x minus 1, and then we have c, which is our y-at asymptote. We take it as it is, and this is just going to be a plus 2. So we need to go and find the value of a. So when we want to find the value of a, we look at where our hyperbola is actually passing, the point that we already know. So this is the point that we know, the origin, and is actually at 0 and 0. This is the origin. Yes, yeah, there we go. I will actually be at 0 and 0. So we are going to substitute that point to what we actually have already here on the function. So we can say your y is equal to 0. Your y is actually 0 equals to a, and then wherever you see x, you also put 0, minus 1 plus 2, and then this is going to give me then a is -1, so it's 0 is equals to -a, and then plus 2. So if you transpose a to the other side, our a will actually be 2. So we have the value of a. Then we can go back and substitute. And then it means our g of x will actually be a equals to 2 over x minus 1 then plus 2, which is also be written as y is equals to 2 y is equals to 2 over x minus 1 and then plus 2. Yes, that's it. It's the same as what they actually wanted here. It's the same. It's our g of x. And then as soon as you have everything answered, as soon as you answer the question, please write down the equations for the information that we later on use for your information. So don't forget that your y is equals to 2 over x minus 1 plus 2. That's the equation of your hyperbola.